Hi there. In this video, we will explore additional attribute type constraints and how we can define our own types. Quick refresher on what is a type constraint. To put it simply, when you set a type constraint on an attribute, you are enforcing a rule that your defined attribute can only hold a specific type of a value. For example, in the previous video, we did see that if we set the age attribute to be an integer by int type constraint, then we cannot assign a string value to that attribute. This is where the type constraints come into play, and they allow you to do exactly that, define accepted value types. Let's start by exploring additional attribute types. If you refer to the documentation, we're going to see that there's actually quite a few attribute types we can use. For the attributes we're going to look at, I'm going to add a comment on the top of the age attribute. Now I'm going to do a little bit of a cleanup here. I'm going to rename the age attribute test. I'm also going to remove everything where we set the name attribute and the build function for it. Save that. Also remove everything where we have the comments and where we're printing out the name. And also let's rename the age to test. This is the new attribute we just introduced in our human class. Now let's start by using any attribute type. Now any, as the name implies, it pretty much allows you to set your attribute to any value you can imagine. For example, if I have it set as 20, and if I run the script, it's not going to complain. Or if I set it to HashRef, HashRef, save that, rerun the script, any value works. This is equivalent to not having a type in the first place, but it's just there for you to know that you can use any type to explicitly indicate that any type can be used for this attribute. Next one we can look at is the bool attribute type. If you know booleans, then booleans are truthy or falsy values, which are usually represented by 1 or 0. So if I try to leave this as a hash reference, rerun the script, this is going to complain, saying that it does not accept a hash reference for a bool type. However, if I set this to 1, save the script, rerun it, it's not going to complain. And maybe it's also going to help if I'm going to do warn, dumper, human, test, save the script, rerun it. I'm going to see this is set to 1, or if I say 0, then this is going to be 0. So 1 for truthy and 0 for falsy. Alright, let's check the num. Now num works very similar to integer that we already used for setting the age. However, an integer cannot have any numbers after the decimal place. So for example, if I reuse the integer type we used before and try to set the test to 22.12, save it, rerun the script, is going to complain because the value 22 has 12 at the decimal place, and that's not a valid integer. However, if I now change that to num type, which can be any type of number, and rerun the script, this is going to pass. Now the next one is going to be string. If we use that, save the class, go back to the test script, and if I replace this to, let's say, HashRef, save our script, rerun it, is going to complain that the hash is not accepted for string. If I set this, for example, to hello, this is going to work just fine. You're seeing hello printed to the console. Now, after string, type is going to be a class name. A class name, you don't provide is a type of a class name itself, literally, but instead you do provide a class name, a package. For example, this could be our own human class. So I set this to human, and if I rerun the script as it is now, it's going to say that the human does not pass with a value of hello. Now what we can do, we can actually say human and create a new instance of this. If I rerun the script, this is going to pass because now the test attribute holds a value that is an instance of a human class. So basically your attributes can become instances of other classes, such as utility models and so on. The next one is going to be ScalarRef. If we use that, save the script and rerun it, it's going to fail. And if I change this to, let's say, let's going to define a new scalar, which is my value equals 1. And if I provide this as a reference, backslash, $1, oops, it's going to be value, save it, rerun the script. This is going to pass because we have a reference to the value variable, which is a scalar. Now the next after that, we have ArrayRef. If I use the ArrayRef, go to the script. As you can imagine, we now can use ArrayRefs. Let's say 1, 2, and 3. If I run this, this is going to print our ArrayRef with values 1, 2, 3. Now the interesting thing about ArrayRef, you can also provide square brackets and define what type of elements this ArrayRef attribute should hold. For example, you could say that I want ArrayRef of human instances. So if I save this, rerun the script, this is going to complain because now our ArrayRef, which is defined here by setting the attribute test, which value is 1, 2, 3, this ArrayRef doesn't hold instances of human. If I replace these values with, let's say, human new for the first value and human new for the second value and rerun the script, this is going to pass because we now have an ArrayRef of 2 values that are instances of human. Now afterwards, let's check the hash reference. As you can imagine, it works very similar. So we have a HashRef, which shouldn't accept the ArrayRef now. And if we rerun the script, we're going to see the validation error. If I change this to empty HashRef, this is going to pass. Interesting thing is that you can also define a type of your HashRef when it comes to what type of values this HashRef should hold. Now what I could say that I want my HashRef to contain a list of keys with integers. So I can say HashRef and int, and if I rerun this, this is going to pass because technically this is an empty HashRef, so there are no validation errors. However, if I would say a for my key and set that to 12.12, save it, rerun the script, this is going to fail because I'm saying that my hash reference should contain keys that are pointing to values that are integers. As we saw before, when we're using integer, we cannot use numbers with decimal values. So now if I change this to just 12, rerun the script, this is going to pass. And I can add more keys, for example, b equals 2, and so on. If I rerun this, this is still passing. Now while we're here, it's also worth noting that you can use a pipe symbol. And the pipe symbol allows you to define multiple types that are accepted for your HashRef values or for ArrayRef values. Now I can say that I would like to accept integers and numbers. Well, this doesn't make a lot of sense in this case because we could just use the number and it would accept both integers and numbers with decimal numbers. For sake of example, let's leave it as it is. And now if I change the b to 2.12, save this, rerun it, is going to pass because we're saying that I would like a HashRef for this attribute to contain values which are a type of integer or number. Now if we did the same for ArrayRef, this would behave exactly the same. If I go back and I change this to ArrayRef by using square brackets, I'm just going to change the brackets here, save this, and we also need to remove the keys as such. Save that. Rerun our, looks like I didn't save the human class, so save that and rerun the script. This is now going to print out ArrayRef with 2 values, which is integer of 12 and 2.12, which is a decimal. Now last 2 attributes we're going to explore are called CodeRef and Object. Now CodeRef, if we use that, replace the ArrayRef, save this, and for the test script, set this to anonymous subroutine such as sub, curly brackets. Let's do 1 plus 2, save that from the script, without subroutine dummy. So that means that this is a subroutine reference. In order for us to invoke that, we need to dereference it and use parentheses. So if we save that, rerun the script, this is going to print out 3 because we said that attribute test holds a code reference which does 1 plus 2, and we access the test attribute, dereferenced it, and invoke the function, which in turn return number 3. Now the final attribute type I'd like us to look at is called object. An object pretty much says that you can define this attribute to be any type of object. Now before, we saw that we can say that an attribute can be a specific class. When you say that an attribute is an object, then that attribute can be of any class. For example, if I would set the test to human new, and if we remove the dereferencing, save that, rerun our script, we can see that our human class is accepted. We could also do, for sake of example, we can copy our human class. So copy, and if we just do the paste, and if we rename this to, let's say, human2, okay, and we need to say the package name is human2, and I'll go back to our test script and say we want to also use the human2, save that, and let's replace this class name with human2 as well. Save the script, rerun it, and it works just fine. You can see that this is a blessed hash reference of a type human2. So pretty much object means that you can use any type of instance of a class for that attribute. For sake of housekeeping, I'm going to remove the human2 class. Say yes, delete that. And also in our test script, I'm going to revert back to using human class, not the human2. And we can actually just remove this use, and this human2 will become a human. We save that, so run our script. Okay, this looks good. Now using default attribute types is pretty much going to work most of the time. However, there can be scenarios where you might want to use a custom type. For example, if you want an integer, but you want that attribute of an integer to only be larger than 10. In that case, you cannot achieve that by setting your attribute to just being an ISA of a type int. Now what we can do, we can actually use a module called mouse util type constraints that allows us to define our own types. Now the first thing what we're going to do, we're going to make sure that this module is installed by running cpnm mouse, util, and type with uppercase and constraint with uppercase as well. If we run that, so this is most likely going to be already installed. And if not for you, then you can just wait a minute or two and come back when this has done installing. Now if we go to our human class, what I'm going to do, I'm going to use util type constraints. Now let's introduce the type that we talked about before. For example, where we want our numbers to be specifically integers that are larger than 10 to be accepted as a type for our attribute. So what we can do, we can type subtype, then the name or type, which in this case, I'm going to just call it custom. The next thing we want to do, we want to use the fat arrow notation, and we want to say that this is going to be as int, so we give it a base type where we say we want the custom type to first of all be a number, and then what we can do, we can introduce validation using where keyword and the condition between the curly brackets. Now the value that we're going to get for that type is going to be in $_, and there we can say that we want our value to be larger than 10. Now if we save that, well, first of all add a semicolon, save the file, and also we need to use it for our test attribute. I'll save the human class, go back to the test.pl, and if we just say that this is an integer of value 2, save the test script, rerun it, so it's going to be pro test.pl is going to complain. This is because we said that we want our attribute, which is a custom type, to be defined as an int, and we also want that integer to be larger than 10. So in this case, 2 is not an acceptable value for our attribute test. However, if I set this to 11, save the script file, rerun it, this is going to work just fine. We can see that the value of 11 was accepted and printed out to the console. It can be extremely powerful to use your own custom types to define exactly what type of values you're after. This doesn't have to be just an integer, it can be ArrayRef or string or any other type that you can imagine that adds an extra condition that needs to pass in order for that attribute to be accepted. Now, while we're working with mouseUtil type constraints, I want us to quickly look at one more definition, which is called enum. And what enum does, it allows you to define a certain set of values that can be used for that attribute type. So what I can say here is that I want my custom type of, let's say, my values to only be accepted as, if you use arrow notation and a list context, I'm going to say that my values are going to be either A, B, string B, or C. If I save this and I use this for the test attribute, save the human class, go back to the test script, and let's say I'm going to use a string of D and rerun the script. This is going to fail because value D is not accepted for my values. However, if I try to use a value of A, rerun the script, this is working just fine. And so is, let's say, if I use value of C, rerun the script, and this is still working. Now that's it for this video. We explored attribute type constraints, and we also looked at how we can define our own type constraints in case the default types are not sufficient. I hope you found this video useful, and I'll see you at the next one.